Unit 4, Lesson 9. So, guidelines for solving problems involving rational equations. So, 1, read the problem carefully, understand what's being asked. I know you guys probably will ignore this list, but it's a very helpful list in terms of how to approach story problems. I know a lot of you guys look at story problems and are completely overwhelmed as soon as you see something close to resembling a paragraph. Okay, whenever you see a paragraph, you're like, nope, I don't get it. You haven't even read the first sentence yet. Okay, so with that being said, if you're one of those people, maybe use this as your calming technique. Okay, you know, people how they count 1, 2, 3. What the heck's bothering me? This can be your 1, 2, 3. What's bothering me type of thing for story problems. So introduce a variable to represent an unknown quantity. So usually there's something we don't know. Write an algebraic equation. In this case, a rational equation, because that's what the unit's about. And then solve the equation, and then state the solution. Okay, and then we're going to check the solution to make sure it makes sense. And what does that mean? Do I have a negative length? That wouldn't make sense. Do I have negative time? That wouldn't make sense. Okay, something like that. All right, so if you've taken physics, okay, you got your distance over speed times time, DST. You might be familiar with that. If not, we'll kind of talk about it right now. Okay, so right here's the problem. Completing an endurance race, Shannon, hold on, let me move this up just a little bit. All right. Okay, so completing an endurance race, Shannon cycled for 120 kilometers, then she swam for 12. Okay, her average cycling speed was 8 times faster than her average swimming speed. So Shannon took 9 hours to complete the race. This right here, these are distance, speed, time problems. This is a distance, speed, time table that can help us relate everything. Okay, so distance divided by speed equals how long, right? Like that's, if I'm going somewhere, you know, it's 60 kilometers, and I'm going 60 kilometers an hour, it's going to take 1 hour, right? Just distance, speed, time. All right, so let's highlight the important information first. Important information is she cycled 120 kilometers and she swam for 12. Okay, so that's the what? Is that distance, speed, or time? Distance. Okay, so I'm going to go over here and I'm going to put 120 for the distance for cycling, and I'm going to put 12 for the distance of swimming. Everybody okay so far? So this is where you need to, what is my variable? We don't know how fast she's going, but we know the relationship. Okay, what is the relationship between swimming and cycling? 8 times faster. Yeah, it's 8 times faster. It says right here, her cycling is 8 times faster than her swimming. So if swimming is S, then cycling is what? 8S. Yeah, 8 times faster. 8S. So now we have our distance and speeds labeled. Time is easy. Time is distance over speed. So we're going to go 120 over 8S, 12 over S. Those are our rational equations. Or expressions. They're not equations yet. Okay? Figure it out. Okay? All right. So, let's see here. Information about, so we completed the table. So part B says calculate her average swimming speed. So we're trying to solve for S now. Okay? We're trying to solve for S. What is the one piece of, maybe one number or one piece of information we have not used yet? 9 hours, right? Good. We have not used 9 hours. Okay? Well, this is a race. So we know the total race, it took her 9 hours. So what takes 9 hours? The time plus the swimming. Yeah, swimming time plus cycling time equals 9 hours. So everybody okay with that? Good enough? Okay? All right, so let me look here. We're okay in terms of units because it's in kilometers, and that's what our, we have hours, so we're going to get answers in kilometers an hour. Just keep that in mind in terms of your units. So this is what we're going to have. We're going to have 120 over 8S plus 12 over S equals 9. Okay. So by using our, like some of you might be saying get a common denominator, we can do that, or we can still just do 8s to everything. If I do 8s to everything, see those s's will cancel, so it'll help me out. So that's what I'm going to do on this one. So I'm going to do 8s to everything. That's gone. The s's are gone. 120 plus 8 times 12, that's 96, equals 72s. 120 plus 96 is 216, equals 72s. Divide the 72. 3 is s. Okay, so her swimming speed is 3 what in terms of our units? Kilometers, what was this in? 9 what? 9 hours. So kilometers an hour, okay? So your answer is, her swimming speed is 3 kilometers an hour. Okay, let's pause. Questions? 96. 8 times 12. The s's cancel from the bottom. Yeah. It could be, you can have, Eli, you can have 96s over s if you want, but then the s's will still cancel. Because it's still, you have to do 8 times 12, right? And you'll have 96s over s, and the s's go away. Yep, good question. That's small stuff I'm talking about. Great. I know he's engaged and paying attention. Okay, so everybody get that? So 3 kilometers an hour is how fast she swam. So how fast was she cycling then? Times it by 8, yeah, 24. Just times that answer by 8 to figure out how fast she's cycling. Okay, so it doesn't ask for that, but just so you understand, 24 kilometers an hour is her cycling speed. Okay? All right, we got one more example. Any other questions on that before we do one more? Okay, one more here. Whoa. My scroller has not been very nice. 432. Okay. Move it up just a little bit. All right. So St. Andre's Student Council is traveling from Knoxtown to Harperville, no S, for the Student Council National Conference. So first off, when you guys are reading that first sentence is what? Irrelevant. There's nothing in there mathematically we need to know, okay, other than maybe the places, but they'll say them again. From the travel budget allowed for the trip, the St. Andre's Students Council has 2 options. There's 2 different things. They can leave tonight by bus, so bus is an option, and save 3 hours. There's some numbers there. By leaving tomorrow morning and using the express train. So there's an express train that travels 25 kilometers an hour faster than the bus. So they can leave tonight by bus, or they can leave and save 3 hours, so they'll get there 3 hours faster by leaving tomorrow morning and using the express train. So they're trying to figure out which they want to do. Okay, so if the distance between Knoxtown and Harpersville is 1,500 kilometers, so there's our distance. Determine how long it would take to travel by express train. So try to figure out, if I was just going by the express train route, how long would it take? Okay, so now they don't have the table here for us. We'll make our own table here. Okay, so we have our so we have our distance, our speed, and our time. What are the 2 ways they can travel? What are the 2 types of travel options they have? By what and by what? Bus or train. Okay. Is their distance different or the same? The same. They're going the same distance. They're both going the 1,500 kilometers. So you're going to keep the same distance. Okay, now, this next part is where it gets a little bit confusing. Which one is slower, the bus or train? The bus, right? And it says that how much faster is the train? 25. So do you understand that bus is your S, and then train is your S plus 25? Okay, because it's the faster one. Does that make sense? Okay, and so then we have time. Well, time's already set up. Time is just what we just made. Remember, this column's easy once you have these two filled out. So this one's 1,500 over S. 1,500 over S plus 5. Or 25, excuse me. Okay, now the part that's hard, I think, the hardest part of doing these is how do I set it up? So what am I going to set up here that makes sense? Because we don't have a time. Say that one more time. No, doesn't equal 1,500. Good idea, though. Good idea. Okay, so the bus travels this fast, right, to the same destination. The train travels this fast to the same destination. So they're going to the same destination, right? So we're going to set them equal to each other. Oh, wait. No, sorry, I lied. How much faster is the train in terms of time? I forgot about that part. How much faster is the train in terms of time? I'm sorry. 3 hours. Okay, so time and time. So if I subtracted the bus time from the train time, it would be the 3 hours because the bus is slower. So if the bus took 13 hours and the train took 10 hours, there's your 13 minus 10, so that's your 3. Does that make sense? I just made that up. Yep.
Sorry, so that's your speed, the middle one?
Yep.
You said S plus 25.
Right.
But this is you need 3 hours faster, so wouldn't that also include one of your variables for speed?
No, because 3 hours is a time.
Yeah,
3 hours is not speed. Because right here it tells you, no, it's because it goes 25 kilometers an hour faster, so it gets there 3 hours earlier. So the speed that's gained is 25 kilometers an hour. If you're going that much faster, you save 3 hours. That's what we're about ready to do right now. Yep. So Spencer's saying he's just starting to click that where's the 3 at. So what it's going to be, again, the slowest time minus the faster time will be 3 hours. So 15 over S minus 1,500 over S plus 25 equals 3. Sorry, I forgot that step. Okay, again, just want to make sure you're not just writing out all right down. This is the bus time. This is the train time. Right here. Slower time minus the faster time gives me the 3-hour difference. Okay, so now this is one where we're going to want to what? Like, how do we do this rational expression here? I can't just do plus 25 here. Okay, you can't do that with fractions. We can't cross multiply because it's on opposite sides of the equal sign. So we don't quite want to do that. Common denominator, so we multiply everything by S and S plus 25. So I'm going to go S plus 25, S plus 25, S plus 25. Okay, and so on this one, the S's cancel. On this one, the S plus 25s cancel. Okay, so I'm going to have S plus 25 times 1,500 minus 1,500 times S equals 3S squared plus 75S. Man, my 5's and F's are not very different. 75S. Okay. So I need to multiply this here. So 1,500 times 25, that's 37,500. And then 1,500S minus 1,500S. Okay, so you can see the 1,500S's go away. I'm going to minus this over so I have one side to 0 because I have a quadratic. Okay, I have a quadratic. I can't get rid of the S squared, so when you have an S squared or you have anything squared, it's a quadratic. That's our whole last unit. Okay, and so happens with that is we have to either factor or find the zeros with our calculator as the options. Okay. So I'll move this over. So this whole thing equals 0, this quadratic equation right here. Okay, 3 does go into all of them, so that can make your life a little bit easier. And 37, it's 12,500. Okay, and then you want to factor that by inspection. Okay, you may not see it right off the bat, but it's going to be 100 and 125. So minus 100 plus 125. Those are your two options. Okay, so if I use my zero property, what are my answers here? What's this one? What makes a negative 100 positive or 0? A positive 100, and then what makes the plus 125 0? Negative 125. So my options are 100 or negative 125. Are they both answers, one an answer, or none an answer? This is where you have to do that number 5. Are your answers logical? What is S, guys? What are we solving for right now? Yeah, it's the speed in kilometers an hour. Okay? It's a speed in kilometers an hour. We can't do negative 125 kilometers an hour, so this right here is your answer. Okay, so the speed of the train, or excuse me, the bus, speed of the bus is 100 kilometers an hour. What's the question asked though? How long will it take to travel by train? So how can I use that or finish that by my chart? Yeah, we want to go to time per train. So we know what S is now. So we can just go 1,500 over 100 plus 25. Okay, and that's going to give you 12 hours. So if it takes the train 12 hours, how long is it going to take the bus? 15 hours, right? Just something I didn't ask you that. I'm just asking you out loud to see if you're staying with me. So 15 hours and then 12 hours. All right, any questions on that? Okay, you guys have time to practice this. I think our exit card today will be one of these problems just to see how well you can do. Okay, all right, let's go ahead and pause that.